Implementation of full adder with two half adders and one OR logic gate, right? So this is the most expected questions in exam point of view. Right now what we have to do is, suppose if you have the two half adder, how you are going to design the full adder, right? So the specification which we need to use to design the full adder, by using of the two half adder we should use. One more is the by using of the OR logic gate, right? So to design full adder, first we should know the what is the sum value as well as the carry value of the half adder, then only we can able to design the full adder using the half adder circuit, right? So if you see that half adder we have the, right, so if you see that half adder, so we have the sum, right, so we have the carry, right? What is the expression for sum? A XOR of B, right? What is the expression for carry? A into B, right? This we have obtained from the half adder design, right? So now instead of again designing the one more time half adder, just I'm writing the what is the expression for sum, what is the expression for the carry, right? So now what we have to do, by using this we can draw the logic circuit diagram, right? So what is the sum value? XOR logic gate, right? What is this one? Like this we can write, right? So AND gate, so AB, so this is the right sum value, this is the carry value. Now question is that by using two half adder we need to design the full adder, right? So for that what I'm going to do is I'm going to consider the one half adder. So this is nothing but the one half adder circuit, if you observe here, right? So again I'm going to consider the one more half adder circuit, right? So this is one more half adder circuit, right? So inputs are the AB, then you will be getting the finally one is the sum, another one is the carry, right? The same representation here you can see that XOR gate, AND gate, this is one half adder, this is again one more half adder. So by connecting these, somehow we are going to get the full adder circuit, right? So if you solve this full adder circuit, we will be having the expression for sum as well as the carry, right? What is the expression for sum? A XOR of B XOR of C. What is the expression for carry? AB plus AC plus BC, right? So in some way some people will get A C in plus B C in, right? So C in is the carry from the previous, and right, so finally we need to get something like this, right? So after performing the two half adders we need to find out the output like this. But if you observe the block diagram of the full adder, if you see something like this, how many inputs we will be having? One is A, another one is B, another one is the carry, C in or carry. So finally you will be getting the sum as well as the carry, right? If you observe here in full adder design, we should have the three inputs. Remember this first point, we should have the three inputs value. But if you see that how many inputs value we have, two inputs value, right? It means that finally we should have the three inputs, two outputs, one is said to be sum, another one is said to be carry. But if you observe here, we have as of now only two input value. Now I need to make one of the terminal value as the input, so that I can get the third input value also. Now how to get, right? So if you say this is the one of the half adder, this is another half adder, right? So the moment this you cannot able to take as the input, right? Why you cannot able to take this as the input means, because this is the output terminal, right? So this also not possible output terminal, this is not possible output terminal, this is also output terminal. But somehow if you observe here, what is this terminal? Input terminal, input terminal. It means that my requirement is that I should have the three inputs, but as of now I will be having the only two inputs value. I need to make one more as the input value. So for that either you can take this terminal value or this terminal value, right? Both are correct only, right? So that you will be getting the one more input is nothing but the third input value. So that is nothing but the C in or carry in, right? So one you will be getting the finally sum value, another one you will be getting the carry value. Now see that what is the expression for sum? A XOR of B XOR of C, right? So A XOR of B XOR of C means, so here A B, right? XOR logic gate means what is the output value here? A XOR of B, right? So now what is this value C, right? The moment if you perform A XOR of B in and XOR of C, what the value you will be getting? So finally sum means you should get the A XOR of B XOR of C, right? So finally you should get something like that, right? So A XOR of B XOR of C. See how we will be getting A XOR of B XOR of C. Somehow if I interconnect this one to this one, what is the value here up to here? A XOR of B, right? Now this is one more input terminal value, right? So what is this value C, right? Now again you perform the XOR operation, finally you are getting A XOR of B XOR of B, right? The same way they have connected here, right? If you observe here, the same way they have connected here, one more terminal they have considered as the input. Well, so that you will be getting the 3 input values. So finally we got the output expression as the A XOR of B XOR of C. Now see that here, as we know that A XOR of B XOR of C means sum will be produced in the XOR logic gate. But if you see that where it is producing the carry means in AND gate operation, right? So if you see that here we have the one AND gate, here we have the one more AND gate, but how many final carries we require? Only one carry. So for that what we have to do means, so here we have the two AND gates, so we should make it as the single carry representation. It means that we need to perform the addition operation, right? So I cannot able to take this separate carry, right? So for that what I'm going to do is, right, I'm going to use the OR logic gate, right? If I use the OR logic gate, now what will be happen? These two terminals, right? This will be become the single. So you'll be getting the expression for the carry, right? So you'll be getting the expression not in terms of the AB plus AC plus BC. You will be getting the expression in terms of some other way. But finally, if you observe, this can be implemented in terms of AB plus AC plus BC. The equivalent expression you will be getting something like this, right? So this is how we are going to design the, right, so full adder with the help of the two half adder with one OR logic gate, right? If you want to remember in simple way, right, we can write something like this also. It means that you don't remember the what is the expression for sum of the half adder, what is the expression for the carry of the half adder. So in this design what we are going to do is, as usual, we are considering the two half adders. So half adder 1, one more is the half adder 2, right? So in one half adder we will be getting how many inputs? Only 2, right? In the second half adder, one of the input terminal we are getting as the one more input, nothing but the carry in, right? Now this one of the output of the half adder we are going to connect to this one, so that you will be getting the expression as this sum. Then remaining here carry will be generated in AND gate, right? Same thing what we discussed previous. So here we are going to take the carry as the output value, right? So this also correct representations, right? Let me repeat one more time so that it will be clear for you. So the design is that I am going to consider first half adder, second half adder, right? So if you consider here in the first half adder, you will be having the only two inputs. Then one of the terminal I am going to consider as the input value, so that you will be getting the 3 input value. Once it is done, so we need to remember what is the expression for the full adder is sum, this one carry equal to AB plus AC plus BC, right? So it means that if I connect something like this, I should get the A XOR of B XOR of C. If you observe here, here what is the value? A XOR of B. Here what is the value of C, right? So then if you connect this one to this one, you will be getting A XOR of B XOR of C. So that you will be getting the expression as the sum. Simple way. Then next we need to use the OR gate, right? We know that carry will be generated in the AND gate representation, right? Here also AND gate, here also AND gate, right? But finally how many, right? So we required only one carry, right? But here two carries are generating in the AND gate, right? Now what we are going to do means, we are going to add this AND gate with this AND gate, so that we are going to, by using OR gate, we are going to find out the single carry. That's it, right? So in case if you want to design full adder with the two half subtractors, right? Sorry, full subtractor using two half subtractor means the only extra thing is that here you will be getting the NOT gate, right? The remaining everything is the pretty same, right? Why here you will be getting the NOT gate means the expression for difference equal to A XOR of B bar O equal to A bar B, right? So for that reason here you will be getting the A bar B, A bar B. That remaining everything will be simple, right? I hope you understand. Thank you.